Hi, I'm Nabil, and this is my COMP3011 search engine tool. I will walk you through a live demo and the key code decision, testing, version control, and my GenAI reflection. Here it is, it's running, and first thing before I want to show you the other command, build first, that is actually worked. This is from the earlier that I ran for the first time, and you can see that it crawls to each pages with 6-second politeness window, and then it saves the index to the data, and that file ended up around 1.9 megabyte, and that took 10 to 15 minutes in total. So now let's switch back to this second command. So rather than recrawling every time, you can just load the save index, which is over here, which is much faster and loads instantly. Now, since we load up, let's print thinking. So the print command, it shows the full index entry for a word, which is thinking, and you can see which pages does it shows and how often does it appear, where exactly in the text, and it's the TF-IDF score as well, and that score will drive the ranking in fine, which is our final command. Let's say fine, good. So here it is, it shows based on relevance, the highest score will be on the top all the way to the bottom, and this also works with multiple words like good, friends. So it still works the same based on relevance, and the score, it's the combined of score of good and friend. Now what happens if we search something non-existent? Let's say non-existence. So there it is, it shows the pages not found contain all terms, and instead of crashes, it just gives you a clear messages of the non-existence. Same goes with empty query, let's say just fine. There we go, it shows a clear message. And what about none? And it still shows unknown command. So every single exception you're able to catch to ensure we won't able to get any errors. Okay, so for the code walkthrough, right, the crawler, it uses BFS, which is breadth first search, and this queues over here. I picked BFS over DFS, which is that first, because it visits the main listing pages first before decided to go into the author or it tag pages. What does it do? It pops from the front, and this is what makes it considered BFS. And I also use request.session rather than individual get calls, because it uses the TCP connections between the requests, so there will be even less overhead across all those like 6 seconds gap. And I also use the time.sleep for the politeness window, which is 6 seconds, and that is, I set it on the top here, it only fires if there's more pages left, so no wasted on waiting at the end where there's no pages left. And for the fetch pages, right, if there's any cases the connection is timeout, then it will give a log, a warning, and moves on, so the crawl will not stop to avoid like any disconnections or any timeout. And for the index, it uses the nested dictionary started with words and then URL, then the stats for that word on that pages. And in the dictionary, it gives the order of one lookup for the exact matches, which is basically all we needed here. And from the tracking, which is over here, and for each token, it gets its frequency counted and its position in the text recorded, and that position data will let you extend this to the phrases matching later if you want it. And for compute, TF-IDF runs in a second pass after all the pages are indexed, so you need a full document frequency for every term before you can calculate the IDF. Now for the testing phase, let's type this command, and there you go. It has 105 tests, all passing with 97% total coverage, and the crawler itself has a 97%, and the indexer will have 98%, and the search layer over here is a total of 100%. So all the HTTP calls in the crawler's tests are mock, so no network needed. The first tested TF-IDF value against the known fixture data, so I could assert exact expected number. And for the CLI test, simulates the user input by patching like a missing index file or empty query and so on. So it covers all of the situations so far. So for the version control, what you can see here is all the development is happening in the feature crawler branch over here. So in order to avoid from the main branch here, it stays clean. So it shows that commits follows the semantic conventions such as like test, fix, docs, the feature, and each one it has a scope to a single changes to make sure it stays small increment. And for the git tag, I set it to version 1.00 as an annotated tags to marking as a final submission ready state, and any changes will be adding to version 0.1 or 0.001, it depends. And for the GenAI reflections, I use GitHub Copilot for the three main areas. Like firstly is generating the readme structure, and it gives me a really solid structure of everything, and then but still I need to verify myself and correct some technical part, for example like architecture overview, a bit of a installation part, and again verify myself before committing it. And the second part is the creating the test mock for the crawler test. It does give me a very good suggestion, and it is very useful, which also saves me lots of time figure out which part did I miss out and so on. And lastly, it's also suggesting me the TF-IDF formula. So I hope this walkthrough able to demonstrate everything that you would expect it. So thanks for watching.